Hey everyone, and welcome. You ever stop and think about how your computer, or your phone, or even an ATM seems to, well, think? How does it actually make choices? Today, we're going to peel back the curtain on the simple but incredibly powerful logic that makes all of that possible.
I mean, really think about it. You walk up to an ATM, you pop in your card, and you ask for, say, $100. In a split second, that machine knows whether to give you the cash or to show you that message we all hate to see, insufficient funds. How in the world does it make that decision so fast?
Well, it's not magic, I promise you. It all comes down to the code asking one single fundamental question. And that question starts with the word if. If your balance is greater than $100, then dispense the cash. That's it. That's the starting point for literally every decision a computer makes.
All right, so let's dive right in. The first major concept we're talking about is code that makes decisions. The best way to think about it is like a fork in the road. Your program gets to this point, and it has to choose a path, left or right, yes or no. It can't go both ways. And that choice, it's all powered by something called an if-else statement.
So what is it really? At its heart, an if-else statement is just a professional decision maker. The code checks the condition. If that condition turns out to be true, it does one thing. But if it's false, it does something totally different. Simple as that. It's a clean choice, path A or path B.
So let's break that down. First, the code looks at the condition. For our ATM, the condition is the amount you're asking for less than or equal to your account balance? Second, if the answer is a big yes, if it's true, it goes down the true path and spits out your money. But if the answer is no, if it's false, it has to follow the false path, and that's when it tells you there aren't enough funds.
Okay, so here's what this looks like in the wild, with some actual Python code. Let's say we have a student's score, and it's 75. The code checks the condition. Is the score greater than or equal to 60? Well, 75 is definitely greater than 60, so that's true. The program then prints, congratulations, you passed. But if that score was, say, 50, it would take the other path, the else path, and print, unfortunately, you did not pass.
Okay, but how does the code actually ask that question? Is the score greater than or equal to 60? To do that, we need a special set of tools that let the code compare different values. These things are called operators, and believe me, they are the heart and soul of every decision.
So here they are, the basic tools in our decision-making toolbox. You've got the ones you'd expect, right? Greater than, less than. But I really want you to look at the last two. Equal to, which uses a double equal sign, we'll get to that, and not equal to. These let our code ask some really specific questions.
Okay, I really want you to listen to this next part because it's super important. A double equals sign, double equals, is for asking a question. It's the code asking, hey, are these two things the same? A single equals sign is for giving a command. It's you telling the computer, make this variable equal to this value. Mixing those two up is probably the most common mistake for new programmers, so it's a fantastic one to get right early on.
All right, theory is great, but you know what's better? Actually building something. So let's take everything we've just learned, our if-else fork in the road, and our shiny new comparison tools and create a simple but honestly pretty cool program, an odd or even number calculator.
To build this calculator, we need one more special tool. And I gotta say, it's kind of my favorite. Meet the modulo operator. It's that little percent sign. It looks a bit weird, I know, but all it does is one simple, brilliant thing. It does a division, and then it tells you what the remainder was. That's it, just the leftovers. And this is the trick. This is the whole magic behind our calculator. Think about it. Any even number you can think of, when you divide it by 2, has a remainder of exactly 0. 6 divided by 2 is 3, with nothing left over. But any odd number, like 7, always has a remainder of 1 when you divide by 2. So by checking for that remainder, we can instantly tell if a number is even or odd.
All right, so here's the game plan, step by step. First, our program is going to ask the user for a number. Second, whatever the user types is just text, so we have to convert it into a real number that we can do math with. Third, this is where the magic happens. We use our modulo operator to check if the remainder is 0. And finally, based on that one result, it prints whether the number is even or odd. 4 simple, logical steps.
So our calculator works, and that's awesome. But what happens when things go wrong? You see, good code doesn't just work when everything's perfect. It also knows how to gracefully handle things when they go haywire. We need to make our code bulletproof.
I mean, just imagine it. Our program politely asks for a number, and the user just types in, I don't know, pizza. The code is going to try to do math on a word, it's going to get totally confused, and then bam! It's going to crash. That's not a great experience for anyone. So how do we stop that from happening?
Well, lucky for us, there's this really elegant solution. It's basically a safety net for our code called try and except, and it works exactly like it sounds. The program will try to do something that might be a little risky, like turning the word pizza into a number. And it also sets up a plan B. Except if that risky action totally fails, it'll catch the error and do something else instead of just falling apart.
And here's what that safety net looks like in Python. The code tries to convert the user's input into a whole number. If that fails, which it absolutely will with pizza, it causes a very specific error called a value error. The except block is waiting. It catches that exact error and just prints a nice polite message like invalid input. And the best part? The program keeps running. No crash, no drama, just smooth sailing.
Okay, so we've covered a lot, right? If else, these comparison tools, even handling errors. But why does this one simple idea, this fork in the road, matter so much? Well, because it's not just one idea, it's pretty much the idea.
Seriously, every single piece of smart tech you use is built on this foundation. Checking if your password is correct, that's an if statement. A character in a video game deciding to jump over a pit, that's if the pit is close, else keep running. That recommendation engine that knows exactly what movie you want to watch next, it's just a huge, complicated network of these little decisions. If you liked that movie, then you'll probably like this one. From your social media feed all the way up to a spaceship's guidance system, it all comes back to this one simple fork in the road.
So from now on, when you're using an app or playing a game or getting a recommendation online, just take a second. Because you know the secret now. You know the fundamental logic that's making it all tick behind the scenes. So the real question is, where are you going to see these if-else decisions happening in your world now?